The James Webb Space Telescope has uncovered something astonishing: beams of light that seem to emanate from a city, shining from a far-off point located 4 light years away. This discovery has reignited interest in the potential for extraterrestrial life. The telescope concentrated its observations on Proxima Centauri b, the nearest exoplanet to our solar system, and detected intriguing bright flashes. Could these be indicators of an alien civilization? Stay tuned for more. For many years, both scientists and the general public have been excited about the idea of life beyond Earth, and any evidence that suggests the existence of life in space has been met with great enthusiasm. Then a breakthrough occurred when the James Webb Space Telescope provided strong signs of life somewhere in the universe while scanning the far reaches of space. This powerful telescope detected something remarkable on an exoplanet located in the distant regions. It observed lights that resembled those from extraterrestrial cities, raising the possibility that such cities could exist on that remote world. This concept has sparked a wave of excitement and fascination among scientists who are eager to explore the potential implications of this discovery, as it could mark one of the most significant findings of our time. The discovery hints that intelligent life may exist beyond our current understanding, organizing their civilizations in ways we are just beginning to explore. Looking at these city-like lights located in a stunning 4 light years away, NASA engineers are amazed and wonder how long they could have been visible, waiting for human technology to advance enough to detect them. David Kipping, an astronomer from Columbia University, described the planet where these lights were observed as exceptionally complex. Unlike most rocky planets which absorb sunlight and release energy in the form of infrared radiation, this exoplanet behaves differently because of its unique relationship with its star Proxima. This discovery made by the James Webb Space Telescope highlights the telescope's importance. Its ability to detect infrared wavelengths was critical in capturing the unusual behavior of Proxima b, which is vital for understanding the planet's atmospheric conditions. Researchers plan to continue using this telescope to delve deeper into the planet's atmosphere and even investigate its potential habitability. The James Webb Space Telescope is particularly sensitive to infrared light, enabling it to observe what happens on Proxima Centauri b during its night cycle. Many telescopes struggle to detect faint light in the immense darkness of space, but the Webb telescope can capture even the faintest glimmers of light, making it an ideal tool for confirming whether the so-called city lights on the dark side of Proxima b are real. The telescope can detect artificial light in space if it falls within a very narrow frequency band, much narrower than the light emitted by typical stars. Proxima Centauri b has a dynamic relationship with its star. One of the planet sides faces the star, absorbing its intense energy, while the other side reflects light. As the planet orbits Proxima Centauri, it experiences day and night cycles similar to Earth's, with extreme heat during the day and cooler temperatures at night. The planet's temperature variations are influenced primarily by its composition. For example, if Proxima b lack in atmosphere, the temperature differences between day and night would be extreme. Without the moderating effect of atmospheric gases or oceans, the day side would heat up significantly while the night side would plunge to sub-zero temperatures. This dramatic thermal variation is a key area of interest for astronomers, offering clues about Proxima b's atmospheric makeup. Thanks to the James Webb Space Telescope's unique capability to capture infrared imagery, it can effectively analyze the planet's thermal emissions and provide essential data on its atmospheric properties. Interestingly, the telescope's orbit around Earth aligns with Proxima B's orbit, allowing scientists to make detailed observations of its day-night cycles. Every 11.2 Earth days, if the planet does have an atmosphere, the next step would be to investigate its chemical makeup to determine its potential to support life. The presence of molecules like oxygen, water vapor, and methane would suggest that the planet could harbor life. This analysis involves studying the light passing through the planet's atmosphere, a complicated task. Though the James Webb Space Telescope excels at studying planetary atmospheres, it is primarily designed for other functions. It specializes in monitoring the concentrations of elements like water vapor, carbon dioxide, and methane. While the telescope can't directly detect free oxygen, an important indicator of life, it can look for other significant markers such as ozone, which signifies a healthy atmosphere. As scientists examine the data from the James Webb Space Telescope, the search for distant worlds continues, bringing us ever closer to discovering whether we are alone in the universe. However, it's important to remember that the James Webb Space Telescope can only observe a limited number of exoplanets that are closest to Earth. For more in-depth atmospheric studies, astronomers will rely on ground-based observatories such as the extremely large telescope ELT, set to begin operations in 2028. The ELT is expected to offer a more comprehensive view of distant exoplanet atmospheric structures, providing clearer and more detailed information about their potential to support life. Scientists are eagerly anticipating the launch of future space telescopes like the ELT. In the meantime, the James Webb Telescope remains a critical tool for studying distant exoplanets. Despite its limitations, the Webb Telescope continues to yield valuable insights that could radically reshape our understanding of what lies beyond our solar system. Both now and in the future, researchers are planning ambitious projects for future space telescopes, aiming to develop technologies that reduce the brightness of stars to better observe the planets orbiting them. This is similar to using your hand to shield the sun and improve visibility. These next-generation telescopes will be able to study the faint light reflected by exoplanets more clearly, assisting in analyzing their atmospheres and determining their potential to host life. However, this goal presents a significant challenge. One proposed solution is the use of coronagraphs, devices placed inside the telescope to block out the star's light, while allowing the light from planets to pass through by shaping the light waves precisely. Coronagraphs could diminish the glare from the star, making the faint light from exoplanets more detectable. Another innovative technology is the Star Shade, a large flower-shaped spacecraft that would fly information with a telescope positioned thousands of kilometers away. The Star Shade would block the star's light before it even reaches the telescope, allowing only the light from exoplanets to pass through. This method could be particularly effective for observing planets in the habitable zone of their stars where liquid water and possibly life could exist. However, these technologies require extraordinary precision. For example, the alignment of a star shade must be perfect to within fractions of a millimeter across vast distances. Furthermore, these advancements must overcome the challenges posed by space missions such as miniaturization, energy efficiency, and the ability to endure the harsh conditions of space. Despite these difficulties, the potential benefits are enormous. Successfully observing and analyzing the atmospheres of exoplanets could lead to the discovery of biosignatures, chemical indicators of life such as oxygen, methane, or water vapor in specific ratios, which could suggest biological activity and point to the possibility of Life beyond Earth researchers are also exploring ways to directly image distant exoplanets in greater detail. Future telescopes might be equipped with advanced adaptive optics that can compensate for distortion caused by Earth's atmosphere or the telescope's movements, producing clearer images. Combined with starlight blocking technologies, these improvements could allow scientists not only to detect exoplanets but also to map their surfaces and study their climates. The development of these next-generation space telescopes represents a significant leap forward in our quest to answer one of humanity's most profound questions: are we alone in the universe? By enhancing our ability to observe distant worlds, we edge closer to finding out whether life exists beyond Earth, potentially revolutionizing our understanding of our place in the cosmos. As we move forward in the exploration of the universe, these advancements in telescope technology could fundamentally change how we look at distant exoplanets and the potential for life beyond our planet. The future of SpaceX exploration is brimming with exciting possibilities, with scientists hopeful that the combination of advanced tools like the James Webb Space Telescope and upcoming innovations will allow us to unlock the mysteries of the cosmos. With each new discovery, we are learning more about the vastness of space and the incredible diversity of planets that may exist, many of which could harbor conditions suitable for life. The idea that extraterrestrial civilizations might exist is no longer just a matter of speculation but is becoming an increasingly plausible scientific pursuit. The work of the James Webb Space Telescope, coupled with new technologies like coronagraph and star shades, is bringing us closer to identifying exoplanets where life could thrive. As more data is collected from these advanced space telescopes, the search for habitable planets will continue to push the boundaries of what we know about the universe. The combination of infrared imaging, starlight blocking methods, and detailed atmosphere analysis is set to open up new front in astrobiology, allowing scientists to search for signs of life in places that were once beyond our reach. The excitement surrounding these discoveries is palpable as each new piece of information brings us closer to the groundbreaking possibility that we are not alone in the universe. The future of space exploration holds immense promise, with the potential to answer some of humanity's oldest questions about the existence of life elsewhere in the cosmos in the coming decades. As technology evolves and new telescopes are launched, we may finally have the tools necessary to explore distant worlds in ways that were previously unimaginable. If we are successful in detecting biosignatures or even confirming the existence of alien life, it would mark one of the most significant achievements in human history, transforming our understanding of life, the universe, and our place within it. As we continue our journey into the unknown, the role of telescopes like the James Webb Space Telescope will remain pivotal. They will allow us to peer deeper into space, search for the faintest traces of life, and expand our knowledge of the universe. With every discovery, we are one step closer to answering the most profound question of all: whether life exists beyond Earth. In doing so, we might just unlock the key to understanding the true nature of existence itself. So stay tuned as humanity embarks on an incredible journey to explore the universe with the potential to make discoveries that will shape our understanding of life in ways we have only begun to imagine. The search for life beyond Earth is just beginning, and it promises to be a thrilling ride that will captivate the imagination for generations to come. The journey into space is one of humanity's most ambitious and awe-inspiring endeavors, and with each new advancement in technology, we are getting closer to uncovering the universe's most profound secrets. The idea that we may one day confirm the existence of extraterrestrial civilizations is becoming more of a possibility than ever before. With tools like the James Webb Space Telescope and the development of groundbreaking technologies, we are poised to explore space in ways that were once thought impossible. The excitement surrounding the potential discovery of life elsewhere in the cosmos is palpable, and with each new revelation our sense of wonder and curiosity about the universe continues to grow. Scientists and space enthusiasts alike are eagerly awaiting the results of the next generation of space telescopes, which will allow us to peer even deeper into the farthest reaches of space. The next phase in this incredible exploration involves harnessing new technologies to block out starlight, thereby enabling clearer observations of the faint light emitted by distant exoplanets. This technological leap is vital for studying the characteristics of these exoplanets and analyzing their potential to sustain life. The future of space exploration is not without its challenges. The methods and tools being developed to study exoplanets require unprecedented levels of precision and coordination. The use of coronagraphs to block out the star's light and focus on the light reflected by exoplanets is just one example of how scientists are overcoming these challenges. These devices must be finely tuned to ensure that the faint light from distant planets can be detected while eliminating the overwhelming brightness of their stars. In addition to coronagraphs, another exciting innovation on the horizon is the star shade technology. This concept, a massive flower-shaped spacecraft, would operate in tandem with a telescope, blocking out the star's light before it even reaches the telescope's instruments. This method would be especially useful for studying planets located in the habitable zone of their stars, where conditions may be ideal for life to exist.